of modern science and environment to address solutions for global challenge, parallel session, and plenty of time for networking opportunities. We are honored by the exceptional response to the URICSE conference and the quality and number of contributions. You have made this event possible. We thank you for that and every special recognized and incredible work that committees and volunteers have done to organize this conference. To that, we will do our best to make your stay a success, useful, enjoyable, and unforgettable. And at the end, welcome to this conference. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Professor, for the remark. Now we come to the next agenda, performing doa that will be led by Dr. Jismulatif. Please welcome Dr. Jismulatif.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Ladies and gentlemen, before we pray, let us nod our heads for a few seconds and concentrate on remembering God the Almighty for success of this event. O Lord, the most gracious, the most merciful, we give up our hearts and souls to you, to thanks and ask for forgiveness and protection. O Lord, we have indeed believed, forgive us our sins, save us from the gunning of fire. O Lord, the most gracious, the most merciful, this morning we are gathering in virtual international conference. Therefore, we are praying and expecting your blessings and favor always with us. ربنا ولا تحمل علينا إصرا كما حملته على الذين من قبلنا ربنا ولا تحملنا ما لا طاقة لنا به واعف عنا واغفر لنا وارحمنا أنت مولانا فانصرنا على القوم الكافرين اللهم أرنا الحق حقا وارزقنا اجتنابه وأرنا الباطل باطلا وارزقنا اجتنابه ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين السلام عليكم ورحمة الله وبركاته.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Dr. Jismulatif. Dang merdu bunda berjasa, hang tuah putra teladan. Konferensi internasional telah dibuka. Makalah terbaik kami sajikan. Ladies and gentlemen, in this occasion, we would like to announce the best papers of this international conference. There are 6 best papers with 2 categories which selected by the committee based on the merit and particular criteria. All the names mentioned will be shown on the screen. Student category. Kelly Alvarado et al. From Universidad Francisco de Paula Santander, Colombia. Clara Tarania Pramodia et al. From Universitas Riau, Indonesia. Ignatius Ludi Indra Purnaba et al. From Universitas Gajah Mada, Indonesia. Nismala Dewi et al. Universitas Riau from Indonesia. Professional category. Evi Suryati et al. Universitas Riau, Indonesia. Wajiran et al. Universitas Teknorat Indonesia. Homberg et al. Tudaumat University, Vietnam. Congratulations to all of the best papers. Ladies and gentlemen, this is the end of our opening program. We would like to deliver our sincere appreciation to all of the contributing parties, the Vice Rector of Universitas Riau, the Head of LPPM Universitas Riau, the Secretary of LPPM Universitas Riau, the Chairman of this conference, the keynote speakers, presenters, committee, and distinguished guests. And I close with a pantun. Bujang dan dara tinggi semampai, senyum dan sapa sepanjang hari. Konferensi internasional telah dimulai, menaikkan taraf pendidikan negeri. I'm Anissa Permata Islami. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, I would like to invite you all for the photo session. Please turn on your video camera and we will do some screenshots in 15 seconds. Thank you. Again, please turn on your video camera and we will do some screenshots in 15 seconds. Thank you. Ladies and gentlemen, this is the photo session. Please turn on your video camera and we will do some screenshots in 15 seconds. Thank you. Again, please kindly turn on your video camera because we will do some screenshots in 15 seconds. That's all for the photo session. Thank you. Ladies and gentlemen, after the photo session, we have a short break in 5 minutes in order to have a transition to our next session, which is the keynote speaker's presentation. Kindly please stay tuned in this conference. Thank you.
Udah selesai. Mau berangkat sekarang, udah ada daftar. Daftar lah. Jam 9.
Belum jadi kok. Nanti aja. Kok sampai. Mana sih? Apa ini? If everything ready, MC, we can start now.
Logi ke?
Ladies and gentlemen, welcome to the keynote speaker session. But before we move on, allow me to introduce our great keynote speakers. The first is Professor Dr. Carrie Rinker-Skeffer from University of Chicago, USA. And the second is Professor Dr. Eng Lamberto Tronchin from University of Bologna, Italy. And the third is Professor Dr. Ari Sandhya Fitri from University Riau, Indonesia. And last but not least, Dr. Michiko Hosobuchi from Kyoto University. Now I would like to invite the moderator for our keynote speaker session. Please welcome Dr. Novitri as the moderator for the first and the second keynote speaker presentation.
Thank you, the MC. Well, in this morning, it's time for us to listen, especially the first two keynote speakers. They are both from the North, Professor Dr. Carrie Rinker-Skeffer, and the second one is Associate Professor Dr. Lamberto Tronchin. Well, before we start, I would like also to address many thanks to the first one, Your Excellency of Deputy Rector of Universitas Riau, Professor Dr. Saiful Bahri. And the next is Your Excellency as well. That is the head of Institute of Research and Community Services of Universitas Riau. And also, Your Excellency, the Chair of Conference, Professor Dr. Nur Islami. And next, dear speakers, participants, distinguished guests, ladies and gentlemen, I would like to highlight the first keynote speakers. So it's a time for us for sharing knowledge and expertise from the scientists, stakeholders, academia, professional, and industry, and also government. Well, anyway, Professor Dr. Carrie Rinker-Skeffer, her profile, she received a Bachelor of Science from Biochemistry from the University of Cincinnati, and her PhD is from University of Kentucky, majoring in biochemistry as well. And then her postdoctoral fellowship in cancer biology and the Johns Hopkins School of Medicine, and particularly in identifying mechanisms regulating the growth of cancer cells at metastatic series. And then besides, she also enjoying teaching students, especially on science education and public outreach. Next, I also highlight as well, her research focuses on cancers, most cancers, especially prostate cancers, ovarian cancer, kidney cancers, as well as on cells and genes, molecular and cellular on these diseases. So this is more on women's health problem as well as for men's health matter. She is also a productive researcher because she has more than 100 publications, and especially 77 as the main authors, and then 221 co-authors. And next, she is also handling a pilot study at Rifkin Center, investigating how ovarian cancer begins and progresses. And then also, he has educated more than 7,000 people, included university students, and this is free of charge. Well, for this session, we provide for 30 minutes, include a session for question and answers. Prof? Hello, Prof. There in US is in the evening, right, Prof? Anyway, now it's time for us to listen her presentation. The title is What is Science in America Today? Lesson that she has learned from her recent experience with COVID-19. Okay, the time is yours, Prof. Thank you. So the presentation will make, we provide the time, it's about 15 minutes. And it just can be, it can be adjustable, Prof. So time is your, Prof. Nggak dengar?
Dear moderator, maybe Prof. Carrie is still not ready because in the schedule.
Oh really? Yeah.
Prof.
Yeah.
Carrie will talk about the 10
Okay. Okay.
We can continue for the second presentation.
Oh, so we move to second presentation.
Yes.
Yeah, because it's not time, right? We do have break time.
Yeah.
All right. Okay. Sorry. Anyway, ladies and gentlemen, we come to the second one because we use the time a bit early for this presentation. So it's just the first keynote speakers still preparing. So now we come to second keynote speakers. That is Associate Professor Dr. Lamberto Tronchin. So
Professor.
Here, Associate Professor.
Not associate, professor. Full professor.
Oh, full professor. Okay, sorry. That's what I received online. Anyway, we just showed the video, right? For his presentation. All right. Professor Dr. Lamberto Tronchin, she worked at the Department of Architecture, University of Bologna, Italy. In this session, we only observe his video because it's very late morning now in Italy. So now I highlight first the profile of Professor Dr. Lamberto Tronchin. So Professor Lamberto Troncins, he did studying his master's up to PhD degree at the same university. I mean here, the University of Bologna. His PhD degree is in applied physics, particularly on architectural acoustics. And then in brief, his expertise also includes in mechanics of musical instrument and on noise and vibration. He did his postdoctoral scholarship on room acoustics. In addition, he has published more than 200 papers. For your information, during the last 2 years, he has published 21 publications. So 14 papers as main authors and 7 as co-authors. And then in the past, from 2000 and 2008, he was the chair of the musical acoustic group of the Italian Association of Acoustics, acoustic consultant as well, especially in designing and building. And then Professor Troncins also is the president of Italian sections of Audio Engineering Society. And besides, he is also an associate editor of the Journal of the Audio Engineering Society. Then, of course, he has been referee for international journals in European countries. We know that from in West Europe to East Europe. And then now, before we listen to the video of Professor Lamberto Troncins, again from the committee, we also remind, please, the presenters ID rename again according to your registered name, and then your ID papers, and then following also the room number. Thank you very much. Now, we listen together the video from the keynote speaker because it's very late morning there. So that's why he sends the video to us as the committee. Let's we enjoy this presentation. Thank you.
Good morning. My name is Lamberto Tronchin. I'm a professor of environmental applied physics from University of Bologna. I'm pleased to give you this keynote during the URICSE conference, and I wish to thank Professor Noor Islami for having invited me to talk. The title of my keynote is 3D Sound Spatialization in Architectural Acoustics during the era of pandemic. This is the summary of my talk. After a brief introduction, I will focus about the problem that I will going to study with you. And I'm going to focus about 3D auralization. 3D auralization is a method that we employ when we are going to reproduce virtually the acoustics of a room. Moreover, I will focus also about nonlinear convolution. Nonlinear convolution is another method that we normally have developed when we were going to study the acoustics of musical instruments, but we apply this method together with 3D auralization. I'm going to show you also some tools that we have developed in my university with my team, and some practical case studies of system emulation. The first case study will be the Teatro Gallia of Rimini. This is a theater that has been reconstructed a few years ago after the bombing during the Second World War. However, the movie that I have prepared about this theater has a fair acoustics, a fair sound for a reproduction by means of Zoom. For this reason, instead of the theater, I will show you a movie that we have developed about the Basilica of San Vitale in Ravenna, where the audio is less important and is more important to see also visually what happened during the reconstruction. The question is, first of all, which are the loudspeakers that we can employ during the realization? In other words, who is where, which is the loudspeaker, and where is the loudspeaker? For example, in this picture, you can see what we normally have when we are dealing with the Dolby Surround or similar system, in which we have some loudspeaker in front of us, our loudspeaker on the back, and some loudspeaker sometimes on the left or the right. But when we are going to reproduce the sound, we need to reproduce some sources. So the question is, where are they? They are there. For example, we have a speaker in front of us, or a singer in front of us. We have some musicians on the left, in front or the back. Other people playing music or giving a speech or ballet or other things in the front, in the right side, or in the back, in the right side. Finally, the question is also, where we are, you are there. So it means that you wish to experiment this virtual reconstruction in a specific environment, in a specific room. For example, an opera house. So we need also to take into account the acoustics of that specific opera house. Which are the methods that we normally can employ when we are going to reproduce the acoustics virtually? We have several possibilities. The most common possibility is to use some discrete array. It means that we should use discrete microphones and a discrete number of loudspeakers. For example, if you have an orchestra like this, you could put some microphone on the top of each musician or each group of musicians. And then when you are going to play back, you have several, but a specific, a discrete number of loudspeakers. For example, 5 or 8 or more loudspeakers, but some discrete loudspeaker. This is a normal method that normally we have also in the cinema. But another method that we have already developed in our university is the ambisonic system. It means that we are able to reproduce the sound, putting the loudspeakers in some specific position. The easiest way is to put the loudspeakers in the corner of a room. So if you have a rectangular room, you need to employ 8 different loudspeakers. This was the system that we developed in 2001. That is based on the convolution method. It means that you have some signal, some input response, and by means of convolution, you are able to reconstruct the sound. When you are going to record the music, you need some microphone, like specific microphone, B-format microphone, like this one at the right side, in which you should employ at least, like in this example, 4 different microphones. The other possibility, one more possibility, is to employ the stereo dipole method. The stereo dipole method we have developed in 2005, indeed in the Arlecchino listening room. It employs 2 different loudspeakers in front of you, plus eventually other 2 loudspeakers on the back. And if you are able to properly remove the crosstalk, it means that the sound coming from the loudspeaker in front of you of the left side should focus only in your left ear and not in the right ear. If you are going to employ this filtering system, and here you have the software, the formula in which you can effectively perform this filtering, you will be able to listen the sound exactly in the same way as you are going to listen the sound by means of headphones. But here you can also move, turn your head with the headphone. When you move your head, you cannot fix the headphone. The headphones are moving together with your head. So it's quite better to listen, reproduce music by means of satellite. But there is a third method that we are going now to employ in a new listening room that are going to be finished in 2021 in Faenza. That is a little city, 60,000 inhabitants at 60 kilometers from Bologna. And this listening room will be called Sipario, under the Sipario project, and will employ the well-field system. Well-field system, it means that you have a continuous number of loudspeakers in some arrays. Here you have a picture of continuous loudspeakers. Sometimes these continuous rows are all around you, like a rectangular or quadratic like here. And this means that you are able to reproduce amplitude and phase of a signal that is going to propagate inside the room. This method has a specific possibility that is very useful when you want to simulate what happens in the room, because you could also virtually move the sound sources. On the other hand, with the other system, you couldn't move the sound sources. They were fixed in one position. Here you can pan the position, so for this reason you can hear what happens, eventually also going very close to you and then run away. This is very useful method. Let's go now to the nonlinear convolution. Nonlinear convolution is a method that we started to develop when we were going to simulate the acoustics of musical instruments. In our first paper in 1998, we employed a measurement on violins made by means of MLS system, MLS method, and we employed this measurement of impulse responses in order to emulate by means of convolution the sounds of the musical instruments, the sound of the violin. Of course, this method was only able to reproduce the linear component of the musical instrument, that is normally in the sound chest. This is a new method because after the method MLS, we moved to the new method that is the exponential sine sweep, also called chirps. This method is useful because it was able to separate the linear component of the impulse response from the harmonic distortion. This was not possible to do with the MLS system. For example, here you have a measurement of the impulse responses. So if you are going to play the sine sweep and convolve with the inverse filter, you were able to obtain the impulse responses, and in time domain, the impulse response is here, and what you have before is only the harmonic distortion. So for example, here you have 1 distortion, 2, 3, and so on. So you have different order of harmonic distortion. It means that if your purpose was to simulate only the linear part, you can just withdraw in time domain the component that you need. On the other hand, if you want to emulate also the harmonic distortion, you need to develop a new method that is no more a linear method, but it is a new nonlinear method, a nonlinear convolution. And this is what we developed. We started from the Hammerstein model and we employed the Volterra series for nonlinear system, time invariant system. It means that we are able to add here in the sum not only the linear component, but different, up to infinity in this case, different components, different kernels, depending on the value of this Kn. For example, in my first paper in 2012, I proposed the value of different 5 kernels, from 1 to 5, and this is the value of the kernels. And in another paper of 2015, we developed a new method for measuring the impulse responses that is not only a chirp exponential sine sweep, but a synchronized exponential sine sweep. or better, synchronized cosine sweep. Why cosine and not sine? Because cosine is perfectly symmetric during the origin of the axis. For this reason, we developed a new method that was able to go up to the 10th order. So in my second paper, 2015, I proposed the value also of the other 6th order of harmonic distortion. And this is the paper that we published together with Vanna-Lisa Colli in 2015. This is an example of the results. It means that if you are going to put this different sine sweep inside a system, you have distorted output. You can see the amplitude is different, but not only the amplitude, but also the waveform is different. And when you are going to simulate what happened in the nonlinear system, if you use the proper gain, you have a result that is very similar to the real world. So it means what you really record. On the other hand, if you use a wrong gain, for example, instead of the second one, you want to use the last one, when you simulate the result, you have a completely different result. So it means that this result, so this nonlinear component should also take into account the different gains. So you can understand that the problem is not very easy. These are the tools that we developed. For the measurement of the kernels, we used SheLab. And for the multi-convolution, so the nonlinear convolution, we use a VST plugin. This is an example of the code in SheLab, and this is a picture from the VST that we developed, and we call the Volterra convolver, of course. This is an example of another problem that we found, that when we are going to discretize the waveform, you could have a problem. You can see this part, because the delta Dirac could be shifted in different samples. For this reason, you should be able to correct this mistake by means of a new corrective filter that was able to properly reproduce and obtain a corrected delta Dirac. Because otherwise, when you are going to simulate the nonlinear system with the harmonic distortion that you have obtained by means of a not proper corrected filter, the results are not enough. This is an example of simulation. An emulation of guitar overdrive. The guitar overdrive is a strongly nonlinear sound system. It means that when you are going to play some music or to play just a pure note inside, you have an output with several harmonic distortions. Not only the pure tone here, but several harmonic distortions. So what happened? Happened that we add not only the linear component, but also the first 5 harmonic distortions. So you have here the original, linear, and then second, third, fourth, and fifth order of harmonic distortion. So you can understand that when you are going to simulate a strongly nonlinear system, if you decide to use only the linear one, you have only this one component. If you are going to go up to the 5th, you have a result that is much more similar to the original one. If you are going to simulate up to the 10th order, you have also more signal here. And here you have a comparison between the first 5 harmonic distortion and the original one. You can see that if you are considering only the first 5 harmonic distortion, you are losing all these high frequencies distortions, but you are maintaining this one. 10th order, we found that it was a good compromise, because if you go to upper order, you need a specific acquiring system that is going to record very high frequencies. So this is the reason why we focus on up to the 10th order. And this is another example, a final example of this part. This is about what we obtain in the flute. Here you have a real performance. in the second row, you have the virtual performance that employ only the linear component, inputs responses. And the third row, you have the virtual performance that is going to employ up to fifth order of harmonic distortions. If you give a look to the waveform, I'm sorry that I cannot play here because we are not in presence, I'm in remote giving the whole presentation. And you can give a look only to the waveform here. You can see that in this part of the waveform, here the waveform is very similar to the emulated one, considering the fifth order of harmonic distortion, but the linear one is different. So you can see, just giving a look to the waveform, that the third line is quite better instead of the second one. Now we have the examples. As I told you, originally I supposed to present to you a movie about the Teatro Galli in Rimini, but the sound quality was very bad. And instead of playing a movie of Rimini, I decided to play a different movie about the Basilica of San Vitale. But I still wish to focus about Rimini because this is a theater that was reconstructed and opened just 2 years ago, in 2018, in October, so less than 2 years ago. And the history was this one. It was destroyed during the Second World War. This is a picture that was taken in 1910. And this is a render of the theater. This is the plane, the section of the theater. And what we did this specific operation. So we created a model. We decided to focus also about the different direction of the sound in the model. And it means that we were able to add the different direction of the sound using the head latent transfer function that were measured at MIT in 1995. So, before playing the movie, I wish just to conclude my keynote with these few lines. The Volterra approach is very useful when you want to emulate the harmonic components of system, nonlinear system, of weak nonlinear system. Because if the system is strongly nonlinear, you need also to add not only the harmonic distortion, but also other components of nonlinearity. Then, in order to properly measure the harmonic distortion, you need to develop a corrective filter, or, on the other side, the synchronized cosine signal. Moreover, if you are able to focus the emulation only of weakly nonlinear musical system, like musical instrument, like a violinist, like a flute, we found that the Volterra method is quite good. So we can really be able to provide good results only using the harmonic distortions. Still, we have to make other experiments on other non-linear acoustic or audio systems, especially wave amplifiers that we know that are quite important also for the different marketing reasons. I'm going now to play the movie. It takes 2 minutes. However, remember that in order to properly appreciate the movie and especially the sound, we should make this play, not here in my computer, in remote, but in a listening room, like an ambisonic or wave field synthesis room. Let's now go to the movie. Okay, that's all. Thank you for your attention. Have a good conference and greetings again from Bologna, Italy. Bye.
Moderator, we can continue for the next. Moderator, please.
We go to
Hello, can you hear me?
Okay, now good sound.
Can you hear me okay?
Yes.
Okay, very good, because I wasn't able to hear you, so I was worried. So let's see here.
next, we continue to the next keynote speaker, Professor Dr. Carrie Rinker-Skever. All right. Her presentation title that is about what is science in America today, and then lessons that she has learned from her recent experience with COVID-19, isn't it, Prof? Well, anyway, we highlight first about the professor's profile. We know that she is working now at the Biological Sciences Division at the University of Chicago. And then at the moment, her Scopus index is 35. Briefly, her Bachelor of Science, it is in biochemistry. She did in the University of Cincinnati, and then continue to her PhD in biochemistry as well at University of Kentucky. And then she did as well for her postdoctoral fellowship in cancer biology and the Johns Hopkins School of Medicine. Right, Professor? Okay.
Absolutely.
Now in Indonesia, we're still morning, Prof. But however, in Chicago, I bet it is in the evening. So
yes, it is.
Nice to meet you in this conference.
Very nice to meet you too.
Anyway, I continue more about your profile. So Professor Dr. Carrie Rinker-Skever's focus research that is on cancer, especially on prostate cancer, ovarian cancer, kidney cancers, as well as on cells, gene,
and molecular cellulars on these diseases. So correct me if I'm wrong, Professor. But you know, cancer disease is the strong source of death of the people. So based on the United Nations report, so this is the 5th ranks in the world now. And anyway, Professor Carey also produced more than 100 publications, lots of citation, and in line with her expertise. And then your last publication is just about AXL is a logical molecular target in the head and neck squamous cell carcinoma in 2018. Is it? Ah, all right, thank you. And the one that I like it, that is your what we call it, your publication about the title is Stopping Cancer Before It's Colonized.
Yes.
I impressed this research. Anyway, she is also conducting a pilot study at Rifkin Center at University of Chicago, especially investigating how ovarian cancer begins and progresses. And then she has educated more than 7,000 people, as well as the students. And the good point is you did free of charge, you know, as a team as well. Anyway, now we can't wait to listen to your presentation entitled, as I spoken before. So what is science in America? And then what is lesson learned during COVID-19? Thank you.
Thank you.
Time is yours. So we provide about 30 minutes, include a session of question and answer. Enjoy
Okay.
the presentation, Prof. So it's
I will do my best to be on time. Let me see if I can do this with my my screen. Do you see my screen now? I hope. I'm the only person in the United States who hasn't used Zoom yet. This is my first time on Zoom. So, you see it okay? Everybody see my, okay. So, thank you so much for your kind introduction. I spent my career, as indicated, on cancer research. Specifically, I focus on the movement of cancer cells from a primary site to a second site. And in many ways, there are parallels with infection. What I came to reason or understand over the years, and especially in the past 5 years, is how much our education system has changed and how much literacy in science has lagged behind. And especially for our undergraduates, I found that they really needed time and energy and dedicated efforts in teaching science. So what I want to talk about today is in particular, one of my undergraduate students, a little conversation we had, but this represents students that I've had over the years, and especially in the last, as I said, 5 years. What I found is that the students lack a bit more of the kind of fundamental sense of how to do science. They know a lot of facts, they know a ton of information, but they don't get much experience actually using the scientific method in labs, in their courses, and in discussions. And what I've also found is that the students tend to, well, there's a lack of the humanities and there's a lack of just the broader sense of the world in many times There's so much effort that's been spent on material knowledge and getting the data, but not as much time thinking about it. And this was brought back to me as I prepared for this, thinking back to my time with Tanya at the University of Kentucky, and how different my education was compared to what I was giving to my students. So this is an example of one of the conversations I had with a pharmacy student who was taking a course in cancer metastasis with me. My course is very different because I focus so much on practical skills. And now the course will change over to being completely on practical skills. But here's how she talked. She had read a book about Henrietta Lacks, the person who was a source of the HeLa cancer cell line. And she looked back to her biology courses and she said, since our first biology class, we learned that things are already discovered. Acknowledging every day a little more and a little more, it makes us feel like all the main discoveries in science make total sense and that they are just basic. They're so easy. For example, until this class, I never wondered how crazy and incredible Gregor Mendel must have sounded. Now that was the guy with the pea pods and figuring out genetics. Think about it. Doesn't it make perfect sense that anybody would be astonished just to think a human being is on the moon? We've come to a point where we don't feel how extraordinary it is that cells for a person, Henrietta Lacks, lived more outside her body than inside of her when she was alive, that they were used to make discoveries, that they're such a quantity that they're way more now than there ever were in her body. Is it normal to think that all these things that could make so much good could come from something but so bad? Is it, I think that most people have lost the ability to see the extraordinary in things. As we know more, we link ideas and make it easy to understand, but we've lost our capacity to be amazed. This really was very stunning to me, because if you lose the ability to be amazed in science, you kind of miss the point. Indeed, we weren't teaching these skills, and we don't teach them in most of our classes. So what she came down to was saying that we have way, and for her experience specifically, we're normalizing the extraordinary. And in her view, she felt that we were losing the main objective. And as I looked at this, because she prepared a little booklet for me as a present, I thought it was really quite profound, and that I needed to redouble my efforts and make more effort in my class to fill in these gaps. And I've worked with a few hundred students now on this. And if I look back, especially since I've had so much time with COVID-19 to think and be in my house, I realized that most students in most of our science classes, we really don't talk about science. We talk about scientific information, but we really don't tell people how things have been discovered. We memorize, we do these things. And we've had a recurring problem in our country, at least, that many people will say on a topic, whether it's something about the environment or it's about COVID-19 or it's something else, that the science is settled. There's no discussion, nothing's needed, no more questions, it's done. Which is silly, because science is never settled, but they don't know. So I see that side. What I got to see during COVID-19, or what I like to call is the COVID time, was that this also permeates some of our higher level administrative leadership, et cetera, in the sciences and medicine. Instead of talking to people about how things were found or the data that they found, we were told to follow the science. Listen to the science. If we respect the science, don't go against the science, as if it were some mystical entity with enlightened views that could tell us what to do. As far as the practical aspects for American citizens, we were admonished to do this. Follow the Enlightenment, don't ask any questions, don't ask why there aren't, issues, changing rules, these things happening. We're done. Now, when I was growing up, I can tell you that people would not just have followed something blindly like that. And at least in our case, we were initially to spend 15 days to slow the disease spread, and then we go forward. None of that's changed. And I realized that our population really doesn't know how to counter scientific questions or how that's put at you as far as data goes. So I think the long-term implications of that have really made me, again, redouble my efforts and work on how to address this. So what these passages to me, this information I just shared, demonstrates the failure of our medical and research establishments and educational system to serve American citizens. And I am part of that. I take responsibility for that too, because science is way too important. It's not a thing. It's not a noun. It's not even a direct object. It's a way of thinking, and it helps us solve problems and learn new things. But it doesn't happen without humans. Our humanity is part of what helps us find cures for things. It's not technology, it's not fancy machines, and it's not zillions of dollars either. That can help, but without the minds of beautiful human minds, it's not going to happen. Scientific knowledge is subject to continual revision, and the scientific thinking is so good for us. It expands cognitive, emotional, creative, and social skills, and science is a social process. We do it with other people. We share with other people. So it reinforced the idea that I had that now more than ever, both students and our society at large would benefit from these skills. So I looked at COVID-19 as a call for me to do what I could to return to fundamentals. I had done quite a bit of work to put together some courses, but I kind of stalled because, that's always hard, it's a challenge, etc. But I want to share that with you now. So I had thought of all these details that I wanted to share, and I realized 20 minutes, are you crazy? You can't get this done in 20 minutes. So I've taken apart the description of the course, and I can make all of these pieces of information plus tools that I use, resources, etc., available to anyone who's interested. But basically, the course focuses on these processes as students learn to use them while they're creating ideas and projects of their own. So they wind up using everything along the way in order to actually have a work product where these all have gone together. So we emphasize learning how to use tools of creativity, how to really use the steps of the scientific method to solve problems. They get to exercise what their intelligences are. And in a group, you have many different ways of thinking. You have many different backgrounds. So that's very good. We also specifically teach team skills, parts of the team. We go over interpretation of data, how you find good questions, how you form testable, falsifiable hypotheses, and design well-controlled experiments. Well, that duplicated, that's not good. This is not double vision, it's my slide. So the focus is on habits of high-performing teams, team research, and they, throughout the time, have the opportunity to share what they're doing along the way. So whether it's writing projects or speaking projects, they have a lot of opportunities to get feedback and get used to taking risks and talking and giving ideas in front of other people. This is the interior component of the brochures, and I can provide, as I said, to everyone. But what I wanted to highlight is one aspect of the course that I think is particularly unusual and has been very, very useful to students. And I call it the studio. In the United States, in humanities departments like English departments, or where there are writing departments where they do a lot of writing, they'll have writing studios or even quantitative learning studios. But we don't have anything like that in most of our science programs, at least not that I know of. So what I developed the studio to be is a place where students can come and talk to each other. I'm there to serve as a resource. We have resource materials, and that's so that it's kind of almost like a writer's room. People work on writing skills. speaking skills, but also on their science skills. And it really works well. It takes time and effort, but it works well. And I think it's something, especially for writing and especially for telling information, speaking about information in a way that's a narrative as a story, while keeping it very information rich, is something we don't do. We don't teach it all to our students. We really don't spend a lot of time even sharing stories about how science is done and how it's been done historically. And that's something that I realized that was missing, and it was very beneficial to me when I was in graduate school. So basically the studio is a place where I want it to be a place where the students want to come and want to interact, and they really get into depth on things. And that also is a place for them to tie the science to the world, because inevitably something will come up on the news, from the news, or something, a story will come up. And now they're integrating that experience of thinking about science and working on science with the greater world. And those have been very separated in the majority of our science courses over the years. Now, I was very worried about going over, so I'll be coming to the next final couple slides, and I can go back in any detail that would be useful. But I have one more question from Anna, my student from Spain. She asked me one that was a real kicker, as I would say. She said, why are there so many people and so little humanity? What is that in our culture? And I thought a lot about it, and actually spent several months researching the question, because I thought it was a good one, an important one. And what I discovered is that by implementing some of the newer philosophies that have grown in power and strength in our universities, postmodernism, cultural Marxism, and some others, they've really de-emphasized what I would call the storytelling, the more humanities method of telling stories and telling the larger history and even what's currently going on in our world. And it's referred to often as the heroic narrative of a story. Actually, a man named Joseph Campbell, who was a comparative, he did comparative studies on mythologies and religion, found patterns back, in the 50s, I would say, but then developed them over time. And he formed what they called a heroic narrative. And the hero's journey, which is depicted in this cycle here, it's a little figure that I can't see right now on my computer, so I can't read it through, but basically it's a story where you have the person that goes off into an adventurous situation and they tackle very difficult things and they go through a process that changes them, and that they come back different and wanting to share information and integrate back. And when you look at stories of the scientist, any graduate student, they can fit that narrative. They call it a monomyth. And seeing your life as that really changes your view on things. And the example that I will not have time to get into in detail, but directly goes with COVID-19, is a story of a single physician, Dr. Vladimir Zelenko, who's in the picture in the middle. He's a private practice physician taking care of a community of people when COVID hit. And his story is one of trying to find a good way to treat a patient early, to intervene in the development of the infection. His resources, and he said a feeling that he had, that inkling that you have that an experiment might just work. It's a hunch, it's a feeling, it's a drive. He pursued that and then went through the battle. And it was a battle that was somewhat, actually largely shaped, at least in our country, on political issues. He found that the early treatment of patients within the first 24 to 48 hours, maybe the first few days of a COVID-19 infection with hydroxychloroquine, which is a very well-known, well-characterized, extensively studied drug, had a dramatic effect for patients. basically, it's a combination of that drug along with zinc, which goes into the cells and actually has the effect on the virus. And then, of course, a follow-up antibiotic that he found worked well together. Unfortunately, that doesn't make a lot of money. And there are higher things that work. And the story of how he's pursued it, how other scientists around the world have too. There's Didier in France, Risch at Yale. There's many others. And now, because Zelenko was willing to stay in the fight for 6 long months with massive, massive pushback and collecting friends along the way that found his work interesting, he's coming to be seen very clearly that he is right. Now, this isn't a big, revelation to the most of the world. I think there are many, many, many countries that appreciate the utility of this drug. But it's a great example in my mind of a modern day current hero's journey using all the tools that would be covered in my course and showing the parts where your humanity, your character, your verve, your willingness to stick with it can really make a difference to patients. And sadly, there are many patients in my country for whom it would have made a difference if they could have had it. So taken together, that's my brief description of something I'm very obsessed, very interested with. I think the education and the support of students and young scientists and any scientist is very important. And that's what I want to dedicate the remainder of my career to. So if there's any questions or anything I can relate on, please let me know. I tend to go over time, so I wanted to make sure I would be short. So that's my presentation. Sure. Okay. Then
Now we open the session for question and answers, especially for the first 3 speakers for proposing questions. So please.
So there's
yeah.
a chat thing, right, that I should look for? Okay, let me look for chat. Oh, here's the chat.
Professor?
Yes, sir. Yes, ma'am.
I'm Novi 3. You may call me Novi as your moderator.
Novi?
Yeah.
Yes, ma'am.
Is it okay? We provide question and answer. We do have about 10 more minutes. Yeah. If there are some questions.
Oh, here's chat.
If not,
so the question.
Yes.
The questions would come in the chat, correct?
Yes. All right.
Gotcha. Okay.
I'm curious to know about your works in focusing, preparing future generation. So you provide young generation, especially university students, so that their works according to scientific ways. So how long have this program has been run by professor in this university? And then, how many students join, and then how significant the result, if we can let to know about this.
Absolutely. So,
right.
So the I have been doing. I started incorporating these practical skills in my courses many years back. And then as I would learn new things or read new things, I would add a little bit more. So the course was on cancer metastasis, but over time it became more and more and more on the techniques and the tools. The students really appreciated it. I mean, some students, they don't like it so much. But after the class got a reputation, people knew what it was about. And about the experience people had, it became very popular. So I would teach it one time a year at that time. I think I need to split it into multiple sessions because we would have maybe 30 students, 28 students, and that's a lot when you have teams and all the various assignments we do. you know, I would say that the response is that some students that are used to always getting A's because they learn one way, they learn in one way, and they might get a B, then they might get upset. But even many of them have come back later and said, boy, I'm glad I learned how to write in that class. You know, I'm glad I took it. The other thing I found was that for many of them, I might have spent an hour talking to them during the quarter, which we're on a quarter, which is 10 weeks. And they would say that of all their years at the university, I had spent more time with them than any other professor. And I thought about it and I thought, we're all busy, but this is really important because our culture's changed in our country. And young people, they don't talk to older people as much as they used to.
Right.
So there's a lot of information just about living that they don't know. And then we have these, we've had this thing happen over time. It's gotten crazy now, but with restrictions on speech and politically correct speech. And so students were afraid to talk. They were afraid to make mistakes or say something. So we were able to just create that environment where people were comfortable by using humor. There's a lot of literature on humor and its ability to promote creativity. And so that became popular too. It was a place where students could be themselves. And so what are the outcomes? I've had many students over the years tell me, I started actually with graduate students with some of this, but I've had many students over the years write to me and say it was the only course they had like it, and they found it was something that could be very useful to them broadly. So I would say the students do well. I see people improve on their skills when they come in, from when they come in to when they end. And by focusing it now and pitching it from the point of view of the skills and the tools and that you need, I think that clarifies things for people. And we still use cancer as a model. That's probably more information than you needed, but so overall, students appreciate it. They learn new skills, often find it to be useful. Some people that are more comfortable learning in another way, that's hard for them, but that's only a small percentage, I'd say. Oh, and how many students? I've probably had 200 students over time with this teaching method, 200, 300 over the years. But this is a new class with the details of it.
All right. Thank you, Prof. We would like to invite Professor Titania. Professor Titania works at Riau University in Pekanbaru. So times is your Prof.
Thank you. Hi, Carrie. Nice to see you after 24 years, right? Okay.
Oh my God. Oh my God.
Yes.
Reunification.
Yes. Well, Carrie,
that's very nice.
Thanks for that very good talk you gave. Very interesting and also very good for our lectures here to know about.
That's what we thought.
Yes, how about to really teach science. Now, I'm interested in your studio course, right? So the studio course that you are developing or have done too. Do you think that studio? Yes. Do you think
the studio is actually part of the class?
Oh, okay.
So it kind of goes along with the class. There's a place. Do you see what I'm saying?
Yes.
So it's not as okay. Sorry.
So the class is okay. What's the name of your class? That course where you have the studio course?
So the class is science as a creative process.
Okay. Yes.
Is the name of the class. Okay.
Yes.
And
yeah.
And then a sub part of the class is a studio that supports the class. It's kind of like
I see.
A biology lecture, but then you have a lab, kind of. But it's not a lab,
yes.
it's a skills.
Yeah.
And my hope is that I can somehow penetrate the humanities. So people who are non-science majors might take a different version of it so that we can get a little out, you know what I mean, outside of the biological sciences and that to the, you know, other parts of the university that they get no experience in the kind of critical skills and such. Anyway, about the studio, you had a question.
Well, actually, okay, I thought the studio was a separate course, so it's in your class, right? So it's what I was trying to make a question. So actually, this class is very good for international collaborations in science and the humanities. Do you think it can be done virtual, and can you have international students virtual at this creative science class?
So
virtual, I mean, like, you know, using this Zoom and
well, that's what I was thinking about as we came upon this, because I don't know if people in Indonesia or other countries that are taking part in this wonderful meeting, I don't know if this whole COVID-19 has made people crazy, but I went COVID crazy. I had a lot of time to think about this, okay? And it occurred to me that, you know, that what we had talked about me visiting and talking about, you know, some of these pieces. I think you could do this over, you know, distance. I don't see any reason why you couldn't.
Yeah, thanks.
I mean,
that's actually.
Thank you, Professor Titania.
I'm sorry about that. Yeah. Thank you very much.
Yeah.
Anybody that wants information, please. And thank you to Dr. I'm sorry. Thank you to everyone.
The question. So anyway, it's such a well presentation from the professor. So if I'm not mistaken, so your studious course is a kind of making bridge, you know, dealing with the misconceptions about science occur in the society, and then it's trying to be settled through the studio course, isn't it, Professor?
So the studio part of it is it's extra hours. So for example, from let's say 3 o'clock in the afternoon to 6 p.m. I'm in a room called the studio, and the studio's big table and you know, computers and, you know, reference books and students can just come in and say, hey, it's kind of like office hours, but for everybody.
Yeah.
So it goes along with the you know, the assignments and things that are in the class.
Yeah.
But it also could work for just students that are in the sciences that need help with something.
Really,
you know,
learning resources there, right? Library.
Bingo. That's another, yes, that's a better way to say it. Yes, ma'am.
Reference and many others, even for the refreshment is also available. So we are very impressed with your presentation, Professor Dr. Carrie Rinker-Sept.
Thank you so much.
Since there is
I can't wait to watch the rest. I'm excited.
Time is also it's up. So we close this, we end this presentation from Professor Dr. Carrie Rinker-Sept. So thank you very much, Professor, for your sharing of your expertise. Thank you very much.
Thank you for the opportunity. Take care.
Yeah.
How do we get up there? Oh, okay. So that's perfect.
Okay. Thank you, Dr. Novitri, as the moderator and also the keynote speakers. Now, I would like to welcome Dr. Daniel Shah as the moderator for the third and also the fourth keynote speakers presentation. Please welcome Dr. Daniel Shah.
Thank you, Anisha. Thank you. Well, everyone, good morning to you all. I do hope that you still stand by and stay with us in this great conference. I've been given honor of handling this the next section of our plenary here, and we got two more panelists in this second plenary sessions. The first keynote speaker, we got Professor Dr. Ari Sandia Fitri, MSc. And the last keynote speaker we got here, Michiko Sabuchi, PhD. So the first opportunity, we would like to invite Professor Dr. Insinyur Ari Sandia Fitri. Good morning, Prof.
Morning, everybody.
Okay.
Nice to meet you all.
Thank you for
morning.
Thank you for being our keynote speaker.
Dr. Daniel Shah.
Thank you, Prof. Thank you. Well, ladies and gentlemen, everyone, I would like to read for you personal information and also credential of this handsome professor. Professor Ari got bachelor degree from University of Samratulangi, Manado. Oh, it's quite far from here. All right. And he got master's degree from Manchester. It is located in the United Kingdom, of course, majoring in engineering, civil engineering faculty. And he pursued his doctoral program from the same university, also in civil engineering faculty. And currently, he's also the dean of engineering faculty of our Riau University. And Professor Ari here, his research interests are in risk analysis, mitigating of natural disaster, including weather modification. And he has got involved various prestigious projects, international and national. And Professor Harry also used to handle infrastructure and transportation safety project. And I don't need to mention his credential here, because his achievements has been a lot, if I should mention here. All right, without further ado, we will invite Professor Harry to present his paper. At this occasion, Professor Ari is going to present his paper entitled Evaluation of the Effectiveness Implementation of Weather Modification Technology for Mitigating Peatland Fires. This is a very hot issue, particularly in our province in Indonesia. Okay, Prof, you got 15 minutes, and then we're going to have question and answer. Time is yours, Prof.
Thank you very much, Dr. Daniel. And I do hope that in At the same time, you will be a professor, Daniel.
All right, thank you. Thank you. Thank you, bro.
All right.
Thank you.
Yes, yeah. We would like to evaluate the effectiveness implementation of the weather modification technology for mitigating peatland fires. Honestly, the implementation of this weather modification technology in Indonesia has been relatively new, and of course, it will challenging as this cutting-edge technology may increase the precipitation rates or rain, we call normally rains, and therefore it may reduce the risk of peat or forest fire hazard in the huge and massive areas. Could I display my presentation?
Yeah, sure, sure.
Okay.
Sure, absolutely.
Host disable participant screen sharing. Please allow me to enable this screen sharing, please, committee. Because in my laptop, there's a pop-up host disabled participants screen sharing.
Okay, Prof.
Okay, it's working now. Thank you. Appreciate that. Hang on. Can you see my presentation here? I see. Yes. Okay.
Yeah, very clear, very clear.
All right. Thank you very much. This is the condition of peatlands all over the world. Peatland area plays a crucial role for maintaining the sustainability of biodiversity conservation and climate regulation, of course, which would provide an important element in supporting human welfare. However, peatlands only cover 3% of the total area on the world, but 30% of the overall carbon storage in the earth was here. This is the fact that you can see the distribution of peatland area all over the world. The most efficient terrestrial ecosystem in storing carbon in the world is peatland area. However, this is a fragile ecosystem as this is performed by the accumulation of dense wet plant materials and carbon components. Hence, during dry season, this area prone to cause peat fires. Peat fire may release carbon into the atmosphere, causing smoke hazard disaster, and also subsequently will cause severe environmental and social disaster. Here, why peat fires become important? We can look at here. Normally, fire in the forest occurs on the top soil or on the trees, but in peatland, it can go under beneath the surface as smoldering fires. This very, very difficult, very, very difficult to abate this, to distinguish this. And if we would like to extinguish this fire, we need a lot of water. And the presence of rain, basically, the presence of rains, again, or precipitation, high precipitation rates will extinguish this fire. This is the condition, this is forest fires, the condition in USA in September 2020 up to now. This in Russia, in Siberia, fires occurred in huge massive area, and in Indonesia during 10 years periods, forest fires and pit fires may reach this East Asia region here and also Africa. Very this is smoke hazard. This smoke hazard may reach a very huge area in Asia and Africa. In fact, Indonesia is ranked 4th in CO2 emission over the last 50 years. And Riau province contributed about peatlands fire occurrences during this 10 years period. The peatlands in Riau covered about 56% the total area in Riau in Indonesia. And during the period of 2014 and 2015, Riau experienced serious fire disasters. Hence, the objective of this paper is how we extinguish these pit fires. One of the solutions by the implementation of weather modification technology. Now, we would like to evaluate the effectiveness application of the weather modification technology in increasing the precipitation rate for mitigation peatland fire in Riau. This is very prestigious project because it involves many departments and agencies and a lot of money poured in this project. This is the background. Weather modification technology is type of human effort in order to minimize disaster by, of course, this peatland fire disaster by enhancing precipitation rates or rain, and as a consequence, we do hope that will reduce peatland fire disaster. This is the methodology, very straightforward. Currently, the application of weather modification technology has been one of the technical solutions to ease the peatland fire in Indonesia. And the state-of-the-art successful in the implementation of weather modification technology for increasing precipitation rates have been reviewed in several countries, such as in USA, Australia, Thailand. However, the evaluation of the reports related to the implementation of weather modification technology for mitigation pit fire are limited. So here, very limited publication related to implementation weather modification technology for mitigating pit fire disaster. Thus, our discussion here is very important as this will contribute to the body of knowledge in the area of pit fire risk mitigation and controls. Now, how to do that? Performing cloud seeding utilization various equipment, such as cloud seeding using this airplane, and this is rocket launcher. I will I will explain later. Artillery and ground-based generator. However, this is very expensive. We realize that, but there's no way. There's very limited options to extinguish pit fire in the world, especially in Indonesia. Here, some of a picture when we together with BPPT, this is the agency that's conduct together with us weather modification technology. And this is the airplane that we use here. And this is a particle generator, ground-based particle generator. And how to do that? how to do that. The weather modification technology basically is performed by mimicking the cloud development process in the sky throughout the cloud seeding activities. A number of hygroscopic particles size less than 10 microns, for example, sodium chloride, was carried by SpaceX airplane. This is airplane, for example, here, and this airplane. And the particles are intentionally injected directly into the clouds of rainfall, the clouds, and expected to occur. This is, we can drop this on the top of a cloud or below the top, below the clouds. Or here, we can also use ground generator. We release it, this is basically sodium chloride basically is salt, but very, very thin, 10 microns in diameter. And also we can use rocket launcher to bringing the salt itself. And this is we do when we conduct this under the cloud base or the cloud surface within the updraft area, because this is basically we use sometimes this when we look at this is the cloud, cumulus cloud. We need this clouds. When we look at this and we go to this cloud, however, based on my experience and our experience, when we try to approach this clouds, the airplane will be very, very bumpy and shocking. And even me, I feel not comfortable when I was in the airplane. That is the condition. Now, why weather modification technology should be applied? Up to now, there has no well-known technology incapable for extinguishing peatland fires in wide escalation area, except by rainfall, again by rainfall, which can be triggered by the application of this weather modification technology. This is why you can use it. I think because maybe the time is very limited, I will pass it. We use this ultra giant nuclei, for example, natrium chloride, 10 up to basically less than 10 microns. Maybe I make a mistake here, less than 10 microns. Now we try to evaluate the use, the implementation of weather modification technology in four areas within Riau province, including Indragiri Hilir Regency, Meranti Island, Palawan, and Sia. Why? Because historically those regions experienced several peat fires in the last few years that caused peatland degradation and hazard disasters. This is why we conduct this research within this area. This is Indonesia basically. This is Sumatra Island. Okay. Now we look at the data of hotspot using this website, and what happened during 2013 up to 2017. There are about 170,000, again 170,000 hotspots occurred within this area. And in one period, May 2014, for example, 4,700 hotspots were detected within this area. Now we try to evaluate the implementation of weather modification technology. In 2014, we performed total 144 days, and within 144 aircraft, here, sorry, I don't know why my computer is blinking. This is 144 days for weather modification technology we conduct in this area. And in 2015, we have conducted about 152 days, and in 2016, 84 days. And what happened after that? For example, we can see this. Why this is blinking? Okay. This is a tropical rain measuring mission satellite. We gathered all information related to hotspots from this satellite. Thank you for NASA and JAXA Japan for providing us this data. We appreciate that. This is precipitation rates during 2014, during the season, for example, here in January and April, and also June, August, and September, October. During this dry season, we have conducted weather modification technology, and what happened, fortunately, during that period, here we have also may obtain temperature very high. Thank you also for Global Forest Watch and also some related organization that provide us some information related to this. For example, during periods of 1st January 2015 and during period of 2015, we identified more than 170,000 hotspots had been occurred in Riau. The implementation of weather modification technology again, 152 days, and again during this period, we conduct weather modification technology January to March and July to August and September to October. Yeah, this is again some data of hotspots. In 2016, again, we conduct weather modification technology 8 days, and every day, every single day, we spread that salt into the sky. This is some data. And how to calculate the effectiveness implementation of weather modification technology. This is the example. For example, here, if we would like to know, for example, to understand, for example, the effectiveness during this period 15 up to 31st July. So we have to obtain precipitation rate for 2013, 2014, and 2015. And if we get this information, so we use this calculation. This is the effectiveness of implementation weather modification technology. We divided this the average of this, for example, the average of 2016 weather modification technology precipitation rates compared to the average of the precipitation rate during 3 years period. And we have this result, PGH 1.65. Once PGS more than 1, that means it's success. Okay, this is how we deal with the evaluation. Okay, this is some some results from various agencies here, 4 agencies, And we can look at this is period of the implementation weather modification technology. Some unsuccessful, some successful, and some unsuccessful again, and some unsuccessful. And we can look at here unsuccessful, success, successful, successful. This is in the period for 2014. This is the result for 2014 for Riau. 70%, the implementation of weather modification contingency, weather modification technology is considered successful. And what happened to 2015? Unfortunately, 2015, relatively not successful. And 2016, 100% successful. Here, we would like to know why it becomes success or unsuccess. Here, this is the reason. First of all, we would like to emphasize, please consider timing for implementation of weather modification technology.
Excuse me, Professor. So we're going to have our times.
Okay, this is almost finished. This is on a recommendation. Please, the success implementation of weather modification technology are largely determined by the following consideration. First of all, the timing initiating for the implementation of weather modification technology. The success implementation influenced by presence of clouds into the targeted areas. That means don't be late. At the end of rainy season, please conduct this. Don't start it when the presence of dry season. Timeline, window opportunity, we need this. How long to apply this? Quality of material also. So please consider the quality of materials. And weather condition, such as humidity, wind direction, speed, wind speed, temperature, convection, so that weather and climate control condition will determine the success. Also, we consider La Nina and El Nino. Okay, I think that's all. And here we use this targeted only method for evaluation of this weather modification technology. My conclusion is the effectiveness application of weather modification technology increased the precipitation rate for mitigation of peatland fire in Riau during 2014-2016, 3 years period. Then this is considered successful. PCH more than 1. However, we should aware that this will be influenced by various meteorological factors such as ENSO phenomenon, MGO, tropical cyclones, low pressure, and topographic factors. Hence, there was a wide room to improve better understanding for enhancing weather modification technology performance, since achieving its objective by establishing strong collaboration among academic researchers, weather modification technology practitioners, weather and meteorological experts. Thank you very much for your attention. Dr. Daniel, this is yours.
Okay, thank you, Prof. Thank you, thanks a lot. So we have now the effectiveness of weather modification here to curb the peatland fires. Thank you, Doctor. And of course, there's some criteria that should be taken into account in mitigating the peatland fire. Some of them are rainy season. We should do it in rainy season. We should take into account material quality and also timeline and set it up. Thank you, Prof. Okay. Well, everyone, we're going to have our final section here. And I'm sure it's going to be also interesting for us. For the final panelists, we got Michiko Hosobuchi, PhD. Madam, Are you here with us? Michiko Hosobuchi. Oh, okay, sorry. We're gonna have question and answer section for Professor Ari. Yeah, sorry, sorry. We're gonna have question and answer, Professor Harry, and so we're gonna want here. All right. Okay, we got so far here. Question from Idral Amri.
Yes.
All right. Mr. Idral, he raised question here. What consideration to choose inject the salt position, top or bottom, to make partitions here? Particles of the cloud. All right. Prof. Harry, can you hear the question? What consideration to choose inject the salt position, top or bottom, to make particles of the cloud? Okay, the Peter got 4 questions here, but we focus on the first question first. What consideration to choose inject the salt position, top or bottom, to make particles of the cloud?
All right.
Yeah, time is yours.
And honestly, this is a very tough question. Yes. This weather modification technology, however, we deal it since 30, 40 years ago, but some questions related to, for example, position is very difficult to understand in general. But here, we look at, this is basically, this is I mentioned about the release of hygroscopic particles are conducted under the cloud base or on the cloud surface within the updraft area. This is sometimes we look at the wind directions. The wind directions. When the updraft area is dominant, so we drop it here in order to make it the particles go up. But when we look at the direction goes down here, we drop it on the top of the clouds. Here again, that's depend on the condition, wind. Sometimes again, the dense of this cloud, the density of these clouds also. When we based on our experience, once we got like snow in the clouds, not only snow, there's like drop of ice. When we got here, so we drop it here. When we get that drop of ice here, we drop it here. So this is not easy to answer that question, because by testing the various parameters, maybe that's can I answer.
Okay. Thank you, Prof. All right. Thank you. Probably we had already got answer from Dr. Harry. We should take into account the wind direction and also the density of the cloud. Some of the answer. Okay. Next, please, everyone. You may raise question via our chatting room here, or maybe you may just raise your hand and raise questions. Or you may straight away talk via our Zoom conference here.
Oh yeah, here the question also how to optimize calculate the sum of salt to meet all the cloud to produce particle rain. This is again
right.
very difficult question because normally an aircraft, for example, we used to here small aircraft. It's this aircraft is only able to carry it up to 2 tons salt. So we only spread up to 2 tons salt in one period.
Okay.
However, sometimes when after that, within let's say 24 hours, if we look at that, not 24 hours, sometimes because the weather should be checked every I forgot I think in the morning and afternoon. Once in the after we drop it in the morning, let's say 11 o'clock, and in the afternoon there is no reaction from the clouds. So we drop it again in the afternoon. So here, Pak Idral, Dr. Idral, we cannot up to now we cannot justify how to optimize calculation of that.
Okay.
Yes.
All right. So the time is quite flexible. If it's not really effective in the morning, we can do it in the afternoon. Okay. I think the others, is still from Dr. Idra. Any consideration the kinds of cloth to use the salt?
Any consideration? All right. Basically, there are many materials. All right, but the one of the not expensive one is that's salt. But because of honestly, because of price and also availability of the salt is can be main consideration.
All right.
Or this weather modification technology application.
Okay. All right. Okay. Okay. Thank you. Thank you, bro. Thank you. All right, ladies and gentlemen. So we have finished in these sections from Professor Harry. If I may conclude here, I just want to make a very short conclusions. We should do the weather modification on rainy day, right? And timelining should be taken into account, and also material quality, right? And it was interesting here because the success, right? We have, as we have already known from the percentage of the table presented by Professor Harry, 75%, right? The success rate, 75%. So it's very effective to curb our peatland fire. Okay, thank you, Professor Harry. Thank you, Professor Harry. Thanks.
Thank you. You're welcome.
Thank you, Dr. Idra and audience. Thanks. So everybody, we're going to the next our panelists in these sections. We're going to invite here. Hang on. Michiko Hosobuchi, PhD. Madam Michiko Hosobuchi. All right. Good morning. Good morning. We can't hear your voice. Madam Michiko, would you activate your speaker, your audio?
Yeah.
All right. Can you hear me?
Yes.
Okay. Thank you. Everyone, we got pretty lady here and friendly in this section. I'm going to read a little bit about her personal information and credential. Michiko Subuchi is a teaching staff for Center for Southeast Asian Studies. Is that right?
Yes.
Right. From Kyoto University, a fellow researcher and the Research Institute for Humanity and Nature Collaborative Researcher, right? And Michiko Subuchi, PhD here, her expertise is in sociology, and he has already conducted some research in Indonesia, particularly in Aceh, Palembang, Jakarta, Central Java, Sidoarjo, Sunda, quite a lot, Palu, Makassar, and Bali since 2004. Wow. So, Michiko, you are very famous here in Indonesia. And she's involved in several tropical peatland projects. Oh, thank you. Thank you. She get involved in combating peatland fire. She conducted collaborative research with the University of Riau in our Institute for Research and Community Service on community revitalization project. She also collaborated with other experts in meteorology, hydrology, soil science, agriculture, economic, and community participation perspectives on community consensus building and community participation. So since April 2020, she's participated in COVID-19 research team with Japan, Singapore, Indonesia, Malaysia, and Finland. Oh, international scope. Right. In Japan, she also teaches at Kanto Gakuen University. She leads research project between Indonesia and Japan and actively shares her experience and research results in Indonesia with Japanese students and practitioners. All right. So, Michiko is going to present her paper entitled, How Can Science and Technology Be Returned to Local Communities as a Measure Against Complex Disasters? So we're gonna have enough knowledge, right? Information, how science help us, right? To combat our complex disasters here. For another 15 minutes, everyone, please join me to welcome Michiko Hosobuchi, PhD. You got 15 minutes. Time is yours.
Yeah, thank you. Thank you for your invitation. I shared my screen. Yeah. Thank you for your invitation. My name is Michiko. JCR Kyoto University and or institutions. Today, I would like to talk about compact disaster from Riau district. My presentation title, How Can Science and Technology Be Returned to Local Communities as a Measure Against Compact Disaster? I have written many of draft directly into the PowerPoint document, so please share your idea and your suggestion. Karena hari ini saya sengaja menulis kata-kata saya dalam bahasa Inggris di slide saya supaya bisa sharing informasi sama teman-teman yang hadir di sini. Karena saya inginnya mau diskusi dari pengalaman saya sendiri dan mau minta tolong nasihat dari peserta semuanya. Let's get started. The convenient effort of COVID-19 pandemic and drastic drops in global energy prices have hit Indonesia's fossil fuel-based energy sector hard, where the country has been rolling over stimulus package. Most of these funds have been driven toward public health and social safety nets. Meanwhile, its energy sector is receiving tax incentives. The Indonesian government has developing economic measures against COVID-19 while encouraging many participants to implement during recovery for the realization of low carbon society. Currently, it is changing mitigation not only through conservation, rehabilitation, and sustainability that are resourceful with great potential for economic development, but also through peatlands. As you all know, peatlands are wetland ecosystems that accumulate dead organic matter when plant litter production outpaces peat decay, usually under considerance of frequent or continuous waterlogging. But peatlands can be efficiently used by several analyzing. First, analyzing it with supply of ecosystem service. Second, analyzing demand and supply of ecosystem service in land use assessment. Third, balancing support and demand in the participatory assessment of peatland use scenario. And fourth, using indicator of land use function to link supply and demand. So the Indonesian government has focused on these resources from early stage and has implemented a policy of internal mitigation to peatlands and resource development. For decades, large area of Indonesian peatlands have been converted mainly into agricultural lands of east crops production and plantation forest area for pulp production and also. The conversion has both short-term economic gain, such as people living in peatland areas has benefit from peatland basic business, which have equality contribute to economic development. However, it poses major environment and economic risk resulting from health and economic damage due to peat fire, soil subsidence, and flooding, potentially leading to falling of millions of hectares of coastal peatlands in the course of the next decade. The very large CO2 emission from burning and oxygen peat and from the loss of globally significant biodiversity contained in natural peat swamp forest. Indonesia, the Indonesian government has a strong commitment to protecting the management peat ecosystem. Apart from collective action from previous regulation efforts, have also been made at field level to restore peat ecosystem through the 3 R's: rewetting, vegetation, and economic revitalization. For example, as of 2018, the Ministry of Environment of Forest has implemented the restoring of peat ecosystem covered an area of 3.1 million hectares by wetting in both concessional and non-concessional areas. In addition, public-private partnership and collaborating project with university has been implemented. a large number of research studies are being conducted in this area daily. As a result, it can be explained by an easy interpretation of composition, such as a disaster caused by large-scale peatland development since the 1890s, which has caused much trouble for local people. The technology is not only used by the company, but by the community and other companies around the concession. Tropical peatlands have so many risks. Tropical peatlands are not only disasters that can be occur as a result of fire, and it is not the only corona affected with fire, haze, flooding, land subsidence, overseas erosion, absence of native species, crops failure, land problems, conflict, and poverty also occur in tropical peatlands. Our development, management, and utilization of peatlands entail not only the risk of natural disaster, but also risk of human disaster. It is also important to remember that the peatlands are home to human and wildlife of plants and animals. In recent years, research studies have been conducted on peatlands and new develops have started, including climate control, water level monitoring, land subsistence assessment, planting of native species, and introduction of new crops. If we only focus on technology and neglect the welfare of people who live in peatlands, we can never manage them sustainability. In addition, no matter how much human effort to exert to prevent natural disaster from occurring, we cannot prevent them from happening. We must not create a structure in which preventive fire outbreak become to top priority and the residents living or residents' lives develop on it. Monitoring only the dry season and not having measures in place to deal with abnormalities in the face in a recipe of disaster. My method, semi-structured interview, participation, observation, and questioning, and so on. My presentation have two concepts. First, complex disaster. Complex disaster when a disaster over the same time or near time occur. For example, a new disaster occurs and causes more damage. Second, another disaster occurs at the same time during the recovery process, and the recovery work must be redone. Or another disaster occurs in defined area and displaces resources such as rescue team and relief supply. For example, in Japan, my country, Tohoku disaster is complex disaster. First, earthquake. Second, tsunami. And after that, occurred disaster, human error disaster. It is nuclear disaster. As a result, complex disaster countermeasure cannot be implemented in one place alone. We have to consider several types or several situations to see or to analyze topic. Second, research in society, research in simulation. It is necessary to analyze each type of disaster and religion where they occur, formulate an ongoing plan, and work together with the public and private sectors to develop long-term disaster recovery and reconstruction measures. Each region should prepare the same disaster management or develop a backup plan to case of simulation or simulation evacuate in nearly or nearby area. For that, we have to build a resilient society. First, risk assessment. Second, appropriate use of water and land and comprehensive planning. Third, participatory construction and ongoing planning and implementation. So, I focus on peatland society from sustainable peatland managed from local community in Riau. When disaster occurs, the only things we can do is reduce the damage caused by the disaster much as possible. It is different of government, ministries, and university to do this alone. Rather, the contribution managed on peatland is protected by local people. This year's Kyoto, my institution, and LPPM Riau University explored in the JICA project from October 2017 to March 2020. I investigating whether there is a mechanism from the voluntary protection of patrons by the local people and their livelihood to be taken care of by the patrons. I explain my research site. Research site is Tanjung Luban. It is so famous place now. Tanjung Luban village is located on the coastal Broncalis district, Riau, with a population of 558 households and 2,097 people. The village of Tanjung Luban, which was the subject of study, became a new village in 2004 when it was separated from the nearby village of Spahat. The inter-village covers an area of 70 hectares, which is unusual large for a single village.
Excuse me, Michiko, you got 3 minutes.
Oh, yeah.
Okay, thank you.
So, we focus on village. Its name Bukit Bakti village. Bakti village or settlement is which the village under study and form. Bakti village sub-village is located on the coast of Strait Malacca and beginning of 19th century. Why we focus this area? Because in 2010, a large fire broke out this area and 2,100 hectares of land burned down. This is history of fire accident. The sad memory still remains in the mind of some people in village. Disaster will rebuild the burning land has motivated stakeholders not only in Riau, but also in many other areas. This is history. This is land use mapping. And this is land use in 2010. So this area have oil palm, second forestry, and oil acacia and grassland, bare land, and also. This is research activity. We have 3 phases. Phase pertama, first phase, canal blocking. It is point examine dry area based on the needs of residence group. Canal blocking will be applied to the dry areas. And also we have instrumental monitoring equipment, groundwater, and rainforest. It is so important, but this area, the fire is not done. This is so problem have been observed, visualized data, non-visualized data. So we pass to phase this phase. For example, visualized data could occur every year due to self-serving decision by experts from outside the country. There is a lack of communication between various experts. Water cannot be distributed owing to canal blocking. It has become a project per project basis and end up with only the construction of infrastructure facilities. So we reflection voice in group of exchange opinion, review sharing data system and monitoring system, and environment education. So phase 2, area management and peatland society development. It is so characteristic project. First, we done water management, the accumulative analysis, calculation, as well as the collection of selection and different data with direct data mining as a result equivalent data planning from several data technician science data. And we monitoring where or canal blocking, spillway, and waterway construction by residents. It is point that non-experts can understand the problem and visualize it is local residents. Local residents or local people have to do to solve this problem. This mapping is made by local people. And monitoring also several partners, blocking canal, and canal underground, monitoring as several partners, monitoring then also. And regular monitoring and repair the canals. Among the hydrological parameters required in canal network master planning, results about building desert and canal and exhaust channel and also air source measure and so on. And providing of later rainforest data and discuss of water level projections. And also firefighting with drone. Resident oriental measure, cost calculation and schedule will be developed not by Kyoto University and LPPM Riau University, but also local residents after discuss it is them and subsequent acquaintance. And we called foreign media. Now, the vegetation, economic revitalization, in many cases, it is characters. The land has depleted after planning, and the cause of depleted wide based on the result on view, the crops were reselected and planted. Regular monitoring and resume of government were conducted, and the result of feedback to residents. And also we made a system of selective crop of different age is also being considered, taking into account the household structure, its residents, family characters, timing of financial requirement. It's a tree banking. And it is the result of plan monitoring planning. It is also, and digitalization also it is example. First, before the project, the residents or local people bought their vegetable from nearby city, Dumai. But now they do that. Seeding of native tree and fruit tree planting or declared peatland also. Land play present. And conclusion, has this project been successful? The Tanjung Lubang village has not had fire outbreak in 2008, 2019, and 2020. This is great achievement. This is not because of our effort of us, but because of the cooperation of the province, district, Sinalmos Forestry, the PT BBHA, and residents, local people. Although there are still many issues to be addressed, it can be said that development system and allow local people to take initiative has been completed. Our project focuses on return to technology to local people. We have to practicalism or our research through the residents. It's immediately. Then we would be able to answer questions from residents immediately rather than drawing a consensus at the beginning of project. It is important to follow dialogue process that we draw consensus from people. We also found that there is skill in this process of dialogue. So this dialogue process, we have succeeded in security and labor market for local people, spreading knowledge and bring out skill in local people. The key were quick to action, continued agreement, and the suggestion on strict forward peatland management, which had not prepared. For example, in the case of peatland dips, visualizing or peatland cost of mapping on color code. And also, completely different information. Water level information is stored in cloud, and current water level and changing, as well as dangerous water level, are displayed in graph. Residents living near the river or peatland can check this information by selecting the observation point from the map information on web screen. The water level information is updated every hour during normal time, and normal time it is a fire, or every 10 minutes during a heavy rain. We are planning to compare information, the movement achievement of all stakeholders in Riau province from 2008 to September 2020, and to design a database for sustainable peatland management from the local residents. We also examine indicators in the area climate, water usage, soil, economy, and society, land ownership, private ownership, livelihood information of population, organization, and also. This case study differed with a direct with a large number of acacia and in the industrial forest plantation and Malaysia result. The key to handling disaster to be prepared, and this during normal season. We provide training on peatland society, version of forestry management or peatland management that take into account living food.
Excuse me, Michiko, could you make it quickly?
Yeah, I'm so sorry. So pointing, we have to build strategy for peatland management. This is point. So have to share information and quick response and prepare normal time than disaster time. Yeah, thank you. I'm so sorry.
Thank you. Thank you. Thank you. Thank you, Michiko. All right, everyone. So we're gonna move to question and answer. So far we have already got some question here from Dr. Sapihaldo. All right, okay. Good morning, sir.
Morning, sir. Morning.
The Dean of
How are you?
Critical Science Faculty. The question is, how are the results of your research and your recommendation regarding collaboration between the government and private sector regarding environmental damage? Do you get the point, Michiko? The questions. I repeat once again, how are the results of your research and your recommendation regarding collaboration between the government and private sector regarding environmental damage? Okay, all right. Okay, you answer.
Thank you, Mr. Daniel. Thank you.
Yeah, you're welcome, sir. Yeah, Michiko?
Yeah. In my opinion, the government is promoting the 3 R's, but I think it needs to understand society. And society have to understand managing peatland society.
All right.
Because discussion is past process. We have to do step by step, each stakeholder.
All right, okay. So if we may conclude, there should be coordination, right? Right. Very effective and intense coordination with government and local people, right? In order this program to be effective. Okay, Dr. Sapihardo?
This is, I think, enough. No problem. This is a short time from your information. No problem. Listen.
Okay.
Go ahead.
All right. Thank you, Doctor. And okay, we give chance to the audience, other participants, presenters, who would like to raise question for Michiko.
Mr. Saiful Bahri.
Okay, all right. Okay, Prof. Hello, Prof. Saiful. Prof. Saiful? Yes, sir. You may raise question. Prof. Saiful. Prof. Saiful?
still on. Yes, moderator,
Yes,
Mr. Daniel.
yes, sir. You will raise question now.
Bye. Okay, thank you. Regarding to the University of Riau COA, Center of Excellence, we have a topic, a title about ecosystem, peatland ecosystem and disaster management. It was quite related with the Madam Michiko research about. Could you, on the future, engage with the University of Riau regarding to your field of subject, because we have a COA focusing about peatland ecosystem and disaster management, please. Thank you.
Yes, Michiko. Mr. Saiful suggests there should be further collaborations.
Yeah, I'm so glad.
Right. Okay. So how do you respond there?
I'm so glad to hear that. I do my best, so please, because this is my problem in my institution, because many scientists, many scientists joined this project, but science advanced, so human is not here, not there.
All right. Okay.
But in my opinion, the university is not same situation.
Okay.
So several.
I know that.
So I try to do my best, and I have several sites in there. So not maybe, probably many local people want to join project. Thank you, Prof.
All right. Okay. Thank you. Sure, our collaboration has been answered. So we're gonna be right. Riau University and Ms. Michiko University is going to have a further collaboration in this field. Because Michiko, we have been concerned with the pit line fire. So that's why we do hope that scientists from Riau University may get involved, can be engaged in this project, right? And we do hope that they're going to be sustainability of our project from your university and our university. Okay. I think we have maybe one more question for the audience who would like to raise question for Michiko. You may raise question via our chat room, that's fine. Or you may ask straight away, that's fine. Okay, well, I think we have been at the end of this section, very interesting one. And Michiko had already comprehensively told us about the problems, right? The use of science, right? To help community in combating this peatland fire. It has carried out storm phases, phase one, like canal blocking, right? Installation of monitoring equipment, right? Material and equipment, sorry.
Excuse me, Mr. Moderator.
Yes.
There is one more question in the chat box from Taufik Hendra.
All right. Okay, Mr. Hendra. Okay, yes. The handsome guy. Yeah, Mr. Hendra. Yes, mate. You may raise question.
Okay, thank you, Mr. Daniel Shah. Do you hear my voice?
Yes, sure. Clearly, sir. Yes.
Okay, let me introduce myself. From Madam Michiko Watashiwa Hendrades.
Okay.
Yeah, maybe I would like to ask in English.
Okay.
And how do you find the characteristics of the pit soil in Bengkalis, Riau? Because this is my hometown.
All right. Okay.
Compared to pit land soil in Japan.
Oh,
And
I
then
see. Okay.
I want to follow up what the question, which is Mr. Daniel Shah asked. Are there any opportunities for me to continue research? Maybe I can propose my PhD proposal to continue in this pitland.
Great.
Okay, thank you, Mr. Daniel Shah.
Okay, thank you, Mr. Hendra. So,
arigato gozaimasu.
Arigato gozaimasu. Okay. Michiko?
Thank you for your suggestion. I try to do my best, and because in Japan, we have a peatland, but not tropical peatland, but in Hokkaido, peatland research is so many items to introduce. So many items to get useful items.
Okay.
For Indonesian society. So
all right. Okay.
compare several items and several researches to Riau University.
All right.
Thank you.
Okay.
So do you mean in Bengkalis Riau is more variable that you can get compared to peatland in Japan soil?
Okay. So characteristic of Japan soil peatland with Indonesia?
I think not same because tropical and not tropical is managing soil is a little bit not same. But I'm not soil researcher, but my boss is soil researcher, so I tried to contact him. So I
Okay, maybe later I can contact the PSBB in LPPM. Okay, thank you. Arigato gozaimasu, Madam Michiko.
Okay, thank you, Mr. Hendra. Okay, ladies and gentlemen, we have actually cropped our break time here. Thank you, Michiko. Thank you, everyone. So, as a moderator in this section, I'm gonna finish this section. And thanks for raising questions. Thanks for joining this section. And we're gonna see you after the break. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you, Dr. Daniel Shah, and also thank you for keynote speakers. Well, that's the end of our keynote speaker session. We will have a break approximately in 1 hour, start from now until 1 p.m. Western Indonesia time. After this session, we will have parallel session. And attention to all of the speakers, you will be moved to your specific room based on your paper number. As a gentle reminder, please write your number, your name, your room number, your paper number on your username. Mohon perhatian kepada para presenter untuk mengubah nama username akun menjadi nama, nomor ruangan, dan nomor paper. Thank you for all of the keynote speakers' participation, and also ladies and gentlemen, see you at 1 p.m. for the parallel session. Assalamualaikum warahmatullahi wabarakatuh. Attention to all of the presenters, please do not leave our conference right now because we will have a parallel session at 1 p.m. Western Indonesian time. Please stay tuned on this conference. Thank you. Kepada semua presenter, dimohon untuk tidak meninggalkan konferensi ini karena kita akan mengadakan sesi paralel pada jam 1 siang waktu Indonesia Barat. Terima kasih.
Merbah bersarang di buku bulu. Seiring salam dengan sembah, sembah kami jalan 10. Ambil segenggam batang jerami. Dibuat nak
Halo. Halo Romi. الله أكبر. Baru kok belum orang.
Iya. Iya, cuman itulah surat itu tuh yang apa maunya ke OJK tuh yang mau punya ya kan.